Bienvenidos, Ushamdeed, and welcome Anne Arundel Community College learners from the Spring 2023 semester taking the CTS-233 Section 400 Network Programmability course. This is the Cisco Networking Academy's DEVASC 200-901 Certification Exam Preparation course, and in this tutorial, we're going to be taking a deep dive look here at Packet Tracer 5.6.6, Troubleshooting Common Network Problems. Now, this is the final Packet Tracer activity, the third and final Packet Tracer activity from module number 5. So let's go ahead and dive into Packet Tracer. We're using version 8.2 here to render this. And here is our scenario. We've got a little IP addressing diagram there. We've got some objectives to test connectivity. So let's get right into testing the connectivity. So this topology should look familiar. It's the same topology we've used previously. So let's pull PCB up here and let's give ourselves a little bit more room with which to work on PCB. And it wants us to go to the desktop and to take a look at the web browser. And it wants us to browse over to the www.devasc-netacad.pka server. And we're going to go ahead and click go. And you can see hostname unresolved. Now, what previous activity did we do where we were working with some protocol that would do the name resolution for us? In other words, it would take the domain name here and resolve it to an IP address, which is what the actual computer system is going to need. Well, let's find out what it might be. So it wants us to troubleshoot the basics of configuration here for PCB. Now, we've got this nice visual representation of what the problem might be with the two red arrows facing down. So that could obviously be an issue. But with PCB, let's go ahead and they want us to check to make sure that the TCP stack is installed and working. And this is usually a good common first step is to ping the loopback address of 127.0.0.1. So if I can ping the loopback address, that tells me that the TCP suite of protocols, TCP IP suite of protocols is working. So maybe it's not that. Let's check the config on the interface, right? So we go to the settings here for the interface and we can see that the for the interface there. We go to the settings for the interface and we see that we're getting our interface information via DHCP, but there is no IP address or subnet mask here, right? So we're not getting any DHCP addressing. We're not getting and if we're not getting the addressing, then we're certainly not going to be getting the DHCP default gateway or DNS server information, which would accompany that. Now, we can clearly tell here that and it's going to ask, I just want to make sure here. Yeah, so it wants us to click on, excuse me, on the port status. And if we look over here, we can see that we've got nothing for DHCP, and the port status is right here, this little on box. And so it wants us to click on next to port status. And again, when that was off, that meant that the port was off. And so what we have here, and let me go ahead and click fast forward, is we're waiting. It was orange because we're waiting for spanning tree to converge and to move from the learning and listening, or listening, learning, and then into the forwarding state. So now when we come back to PCB, take a look here. Well, we've got this APIPA address now. So it doesn't look as if we're going to pick up a DHCP address. So what it's asking us to do now is check the IP configuration. You should have provided, you should be provided with an IP address if there's a DHCP server on the network. Now you'll notice that it failed here to reach the DHCP server. So we're going to click the radio button next to static, and we're going to put some static information in here. So 172.16.3.2. And again, it gives us the default Class B subnet mask, but we know that we are a Class C right here. So let's go to the settings. Let's drop our default gateway in here as 172.16.3.1, and the DNS server is going to be the example.com server 64.100.0.10. All right, so now with these settings, do we have any better luck over here if I try to ping, and let's see if we can ping example.com 64.100.0.10. And we're going to let that run. Excuse me. It says you now have the correct information to get to the default gateway. So close the IP configuration. It wants us to click the web browser open. So I'm kind of kicking this off to see what it's going to do. We'll kill it though because it wants us to pull the web browser back up. And we're going to take a look real quickly here as to whether or not we can get out through the internet over here to the outside VLAN interface of the ASA firewall into the DMZ. And can we access this yet? Now, you'll notice there's a red upside down arrow here. So that may be your first indicator, DEVASC-netacad.pka, that this might not work, right? Again, the request fails. So it wants to troubleshoot issues on router 3. And again, if I was to pull this back up here and we were to go over here to the command prompt, we can see the request timed out. What do we have going here? If we try to ping it again, is it going to work? And so while we're waiting for that, it wants us to communicate with the default gateway. So close the web browser, pull up the prompt. Can I ping my default gateway? So we'll kill this, right? We'll come back to that. We're going to try to ping the default gateway 172.16.3.1. So if I couldn't get to the 64.100.0.10, I should be able to get to my default gateway, right? Because I'm literally almost directly connected here through the switch to router number 3. Now, if we hover over router 3 long enough, you can see that this comes up here. And what is the gig 001 IP address set to? Again, we're pinging 172.16.3.1, and the address is transposing the last 2 octets. So on the router, the interface is up, and that's great, but it's got the wrong IP. So when somebody was configuring it, they configured it to 172.16.1.3 instead of 3.1. And so that's what we're going to have to do to resolve that issue. So let's open router 3 up. Let's go ahead and stretch the screen here. We'll go to the CLI. And again, that was gig 001. And we'll go from user exec to privilege exec. If I say show run, you'll see that gig 001, that is the interface that we're after. Let's get into global config, interface gigabit Ethernet 001, and let's just go ahead and change that IP to 172.16.3.1 with the appropriate subnet mask of 255.255.255.0. And now that that's set and it's properly set, I should be able to come over here, and now can I ping my default gateway? We'll take a look at that. I can get to the default gateway. If I can get to the default gateway, I should be able to get out to this example.com web server here, 64.100.0.10. And we'll let that run for a little bit, see what happens while we check in over here and see what's going to be next. So great, we've got communication between PCB and the default gateway. Let's go back to the browser. You can see we can now, we can now get out here, and we can get out to the example.com server. So can I get over here? Well, this red upside down triangle here is telling me different, but let's humor the packet tracer activity, and let's try to pull this back up. And so we found a couple of issues so far. So devasc-netacad.pka, and no, it still does not work. So it wants us to troubleshoot router 1. So if I mouse over router 1 here in the activity, we can see that we've got the 2 interfaces there that are up. We can see the IP addressing on those interfaces. And so from a cursory glance, everything looks okay. Now, it says by looking at the packet tracer work area, we can see that there's a physical problem with the cabling between router 1 and the firewall. Well, let's go ahead and click on router 1. Click on router 1, click on the config tab, and we take a look at the configuration tab here, and it says check the port status on each interface. And so if I click on the interface, you can see the port status is on. And again, this is, I would have preferred that they've, did something that wasn't packet tracer centric, right? So this is like a packet tracer thing that the port status is on. Again, if we were to shut the interface down, so I'm in the interface right here, and you can see, down here, oops, it's not going to give me the interface. Looks like it's kind of hanging a little bit there. And you can see that the interface is on. And so this is kind of, having us come in here and take a look in packet tracer to see the interface is on. I would have preferred maybe that, they have the interface shut down and you've got to bring it back up or something like that. But it is what it is. So when we look, we check the port status of each interface. The interfaces are up, and the network between the devices, the IP address ports at either end of the cable, must fall into that range for communication. And so what about our gig 000? Does it fall within that range? 209.165.200.225? It does. /29 would be, with only 3 bits left, it would be a 248. So everything looks good here. Let's check the firewall. So when we hover over the firewall, you can see that we have a 192 address, and that VLAN 2, that is the outside VLAN, and that's in the 209.165.200, and the IP address there is a 226. So we hovered over, we saw that it's got an acceptable IP. The problem is the cable itself. So we're going to need to re-cable this connection, and that's going to be step 3 right here, where we're going to go ahead and highlight that cable between these two devices, and actually you can see here we've got the connection tab, which is what we're going to ultimately use here, and it's going to be this connection here. So if I click on the white space here and it says then use the delete tool, and I believe that the delete tool is going to be that right there. And you can see this little, it's kind of odd, right? It's got the little sort of back-facing arrow with the X. That's the delete tool. We're trying to get to that interface. So if I click on the delete tool and then come in here and, not interface, we're deleting the cable, and kill the cable. So that is gone, right? So now we would come down, click on connections, click on straight through, copper straight through cable. We're going to click on the firewall, and we're going to choose Ethernet 00, and we're going to run this connection over to, and hold on just one second. Yeah, that should be right. Choose Ethernet 00 as the connection. This is the port assigned to VLAN 1. And see, I think that's a typo in the lab, right? Because if you look over here, it says that's the port assigned to VLAN 1, Ethernet 00, but we're not on VLAN 1 here. We're in VLAN 2. And then we're going to go to the gig 000 interface here. And so we're going to bring that up. And you should now see the icons on both sides. They should turn green. Again, this is probably spanning tree doing its thing. So if I fast forward here, and then we get our green arrow. So now that the arrow is green, let's run the web browser again. And so that is definitely a typo. That is, Ethernet 00 is not VLAN 1. It's VLAN 2, the outside VLAN. And we connected up here to router 1. So definitely note that if you ran into some confusion there. So now we want to pull the web browser up. And let me click go and see if we can get it. Or sometimes you've got to kill it. So let me go ahead and kill it here. And we'll pull the web browser up fresh. That way we get a fresh look at it to make sure that it is still not working. So we're going to go www.devasc-netacad.pka. We hit enter, and it is still not working. Now, how might we also test this to see, okay, well, it's not working. Well, maybe if I was to say ping www.devasc-netacad.pka, is the ping going to work? Well, if I can't hit the web page, right, with the browser, the ping isn't going to work. What we might also do is NS lookup. And you can see that that's the server. So can I even resolve www.devasc-netacad.pka? Does this resolve? And what's interesting is I'm hitting enter here, and it is actually, it looks like it's might be hung up. I hope not, right? So yeah, what's happening there? Yeah, it wasn't doing anything. It is not. Oh, there we go. Okay, finally. All right, so the request timed out, right? I thought it was hung up. I thought I would get it quicker, but the DNS request timed out. So it waited 15,000 milliseconds, which is 15 seconds, before it said, hey, the DNS request timed out. Again, just a couple of different ways that we could look to see, all right, what might the problem be? And so clearly the issue here is going to be that we are not resolving. And again, they wanted you to actually ping. Let me do Control-C here to get out of here. And we'll do exit. So they wanted us to ping as well the 209.165.200.227. And so this may take a little bit here. And while it's doing that, we'll come down because we know the issue is going to be on the DNS side. So what do we got going on here? So we opened up the web browser. We typed in the IP of the DevASC along with a port we wanted to connect to. Or actually, we're going to do that right now. And this is another way to check, to troubleshoot, like, hey, why can I not get there? And we may see that the request is going to time out, right? That's the response that we would expect that we're going to get. Again, if we were to kick off the ping again here and see, hey, can we just ping through to that IP address? Do I have reachability? And we should get the ping, and that's what I'm kind of going to wait for here. And there we go. So we can ping. We know we've got reachability. We can get to the web server, but what if I was to pull it up now and say, okay, well, let me check now and see if I can get to the web server. Maybe the web server is not even running on that box. So what if I go to http://209.165.200.227, and we can put in here :80, right? Now that's the default, but they want us to go ahead and put that in there. Maybe it's running on a different port. And so we're going to go ahead and click go. And we're probably going to get a request timed out, right? And they tell us you should see a request timeout. Now, what might the issue be if it's not on port 80? Is it possibly running and there's our request timeout. What about HTTPS? So that's the problem, is that it's running, the web server's running, it's not running on port 80, it's running on port 443. Again, we have the luxury here to come into the services and click on HTTP and see that HTTP is on, but HTTPS is also on. So wait a second, they're both on, but I can only hit it via HTTPS and not using the domain name, right, or the URL. So what could the issues be? Well, if we were to look at the firewall, maybe that triggered in our mind that, hey, hold on a second. If I can get to it via HTTPS and the HTTP server is actually running, what are the ACLs on the firewall allowing through? They're allowing only they're allowing ping, but for HTTP and HTTPS, they're only allowing HTTPS. And that is why I can hit it with the IP address on port 443, but not on port 80. But there's still one more issue we've got to sort out, because on PCB, I should be able to type in here HTTPS and use the URL domain name, right? The fully qualified domain name here of www.devasc-netacad.pka. And this should work. Again, it's not working here, and that's why I usually like to close this down, because it gives you the impression, oh, it's working, but it's not. So DNS is our issue. We know where we've got to go to sort this out, and that is to the exampleserver.com. We're going to blow this up a little bit here. Go to services. We're going to go to DNS, which is right in the middle there. And you'll notice we don't have any A records here. So let's create the A record with setting the name to www.devasc-netacad.pka. I always want to type com there. And the address is going to be 209.165.200.227. And that is our A record. And we're going to go ahead and click add. And so there it is. The A record has been added. Now, if we were to turn DNS on, also a critical step right there is to make sure you turn the DNS on. If we go back to PCB, go back to the web browser, let it pop up, we now know we've got connectivity through to the firewall. We've addressed all of the issues. We troubleshot the DNS. We know that HTTPS is going to work for www.devasc-netacad.pka, and there it is, right? So what were all the issues we had to sort out? We had to fix a DNS issue. We had the IP addressing issue that we had to sort out. We had to figure out on the firewall that, okay, well, yeah, I guess it's not open for HTTP, but it is open for HTTPS. We had to replace a cable, and we had to do something else up here. Oh, it was the initial IP addressing for PCB. All right, so as you can see, our completion percentage has run up to 100. And that is going to do it. So that is the third and final packet tracer activity for module number 5, where we were troubleshooting common network problems that were definitely built off of the first 2 labs where we did some configuration work. And so this was a really good lab to dig into to try to figure out what exactly is going on. All right, as always, thank you so much for watching, and I hope to see you in the next video.